Welcome dear students, this is Mrs. Clara from Mount Saint Joseph Higher Secondary School, Tirunamalai. Okay, now let's discuss this example, example 2.14. Solve square root of x plus 14 is less than x plus 2. Now we are going to solve and find the value of x for which possible values we get this expression to be satisfied. Okay, now look into this one. Look into this LHS entry, what is given? Square root of x plus 14. Okay, now always the number which is inside the square root has to be positive. Positive in the sense it should be greater than or equal to 0. Okay, if not, if this value, particular value, the value which is inside the square root takes negative value, then the whole number will become a complex number. Is it clear? So we are not going to take the value which is going to be less than 0. So for discussion we are going to take only the value which is going to be a positive number. Did you understand? So this concept is very simple until you understand it properly. So listen carefully students. இந்த ஸ்கொயர் ரூட் உள்ள இருக்கிற நம்பர் எப்போதுமே பாசிட்டிவாக தான் இருக்கணும். ஸோ பாசிட்டிவாக இல்லை நெகட்டிவாக இருந்துச்சுன்னா இட் வில் பிகம் அ காம்ப்ளெக்ஸ் நம்பர். இமேஜினரி நம்பர் நம்ம சொல்கிறோம் இல்லையா, அந்த மாதிரி காம்ப்ளெக்ஸ் நம்பர் தட் யூ வில் லேர்ன் இன் யுவர் செகண்ட் இயர் ஆஃப் ஹையர் செகண்டரி. ஓகே, இப்போ நமக்கு அது தேவையில்லை. அப்போது கண்டிப்பாக இந்த எக்ஸ் ப்ளஸ் 14 இந்த எக்ஸோட நம்பர் வந்து என்ன எடுக்க போகிறோம்னா, அதை ஆட் பண்ணும் போது இது வந்து எப்படி இருக்கணும், கிரேட்டர் தென் ஆர் ஈக்குவல் டு 0 இருக்கணும். இதுதான் ரொம்ப முக்கியமான கருத்து இந்த இன்இக்வாலிட்டியில். ஸோ தட்ஸ் வை ஐம் கோயிங் ஆன் டெல்லிங் யூ. ஓகே, கான்சென்ட்ரேட் ஆன் திஸ். அப்போ if I assign the value of x to be, let us assume if I assign the value of x to be minus 14, automatically this term will be 0. Okay, now if I assign the value x is equal to minus 15, you just see what happens. Minus 15 plus 14 naka enna aidum, it will become minus 1 aidum. So that is not possible here. Appa this value cannot be assigned. Now if I take x is equal to minus 13, x is equal to minus 12 eduthu paarenga. So now minus 13 are plus 1, minus 12 na plus 2. So now this one, these two values are eligible. Not only these two. If I take x is equal to minus 11, minus 10 and it goes on. Okay, so upper concluding this, what I can say now, I can say that x can take the value greater than or equal to, x can take the value greater than or equal to minus 14. Amadane. Now look into this real line la minus value. If inga minus 14 irukna minus 13, minus 14 vida minus 13 da enadhu periya value. If it goes towards this side, this becomes a greater value. Okay, so now that's why we have taken x is greater than or equal to minus 14. Okay, appo இந்த பக்கம் இருக்கிறது வந்து greater than or equal to 0 ஆயிடுச்சுன்னா, இந்த சைடில் இருக்கிறது greater than or equal to 0 னா, இந்த சைடில் இருக்கிற எலமெண்ட்டும் கண்டிப்பா it will be greater than or equal to 0. So what is the next case? I can say that x plus 2 is greater than or equal to 0. So this implies what? X is greater than or equal to minus 2. Amavaliya. Now we are going to take these two conditions on the number line. Okay, now let's check it. Now look into this. Paranga 0, inga minus 2, inga approximate. This becomes approximate value. So x is greater than or equal to minus 14, x is greater than or equal to minus 2 இருக்கு. அப்படி பார்க்கும்போது இந்த சைடில் இருக்கிற வேல்யூஸ் எதுவுமே நமக்கு என்ன ஆகாது, சொல்யூஷன் ஆகாது. இதை தாண்டி இருக்கிற வேல்யூஸ் தான் நமக்கு என்ன கிடைக்கும்னா சொல்யூஷனை கொடுக்கும் அப்படின்னு சொல்லிட்டு நமக்கு இங்கே கொடுத்துருக்கிற வந்திருக்கிற வேல்யூஸ் நமக்கு சொல்லுது. ஓகே, now let's check it whether this condition is true or not. Okay, இப்போ என்ன செய்ய போறோம்னா, we are going to solve this as usual as we solve it for the algebraic expression. Now what shall we do? In order to eliminate the square root, I am going to square on both sides. Now squaring on both sides. Now when we square on both sides, what happen? We'll get x plus 14 is or no? Strictly less than x plus 2 the whole square. Is that no? Okay, now look into this. X plus 14 strictly less than x square plus 4 plus 4x. Is that no? A square plus b square plus 2ab. Okay. Now, shall we bring it everything to that side? Okay. Or if you bring this side, this will become minus x square minus 4x minus 4 plus x and plus 14 less than 0. Okay. Now look into this minus x square minus 4x plus x will give you minus 3x. Now minus 4 plus 14 will give you plus 10. Strictly less than 0. Yes or no? Okay. Now look into this. I don't want this minus sign. So x square, I am going to multiply throughout by negative sign. So x square plus 3x minus 10 will be greater than 0. Yes or no? Greater than, I told you, when we multiply throughout by negative sign, this inequality will change. Okay, so we got it as greater than 0. Now you factorize minus 10. When I add, I will get plus 3. Okay, now look into this. I'll get, what are the two values? Plus 5 and minus 2 if I factorize. Do you agree? Yes. So now x plus 5 into x minus 2 is greater than 0. Now what are the values now? X plus 5 is greater than 0, comma, x minus 2 is greater than 0. So now x is greater than minus 5, comma, x is greater than 2. Okay. Now look into this. X is greater than minus 5. Does this condition is satisfied? No. Because we have taken all the values greater than or equal to minus 2. Yes or no? On the number line we have discussed, it doesn't belong to this quadrant, isn't it? Okay. So now the only possible value is x is greater than 2. Yena? இந்த பக்கம் 0 தாண்டி இங்க இருக்கிற greater than x greater than 2 ஓட values தான் நமக்கு possible ஆன values. Is it clear, students? Okay. Students, let's discuss the example 2.15. This is also a very simple logic தான். Okay. Now look into this. Here also we have the square root, isn't it? Square root of 6 minus 4x minus x squared equal to x plus 4. Okay. Now look into this. Here also the same concept we are going to use. The number which are present inside the square root should definitely be greater than or equal to 0. If not, it will be a complex number, which is not necessary here. Okay. So now we are going, if this number on the LHS, if the number is greater than or equal to 0, automatically the number which is present on the right hand side will also be greater than or equal to 0. You agree that? Yes. Now, so x plus 4 is greater than or equal to 0. Yes or no? Yes? Okay. Then if x plus 4 is greater than or equal to 0, this implies x will be greater than or equal to minus 4. Do you agree this? So the condition x will be greater than or equal to minus 4. Okay. Now look into this. Now as usual we are going to solve this equation. Square root of 6 minus 4x minus x squared equal to x plus 4. Now squaring. We are going to squaring on both sides. I am going to square on both sides. Now look into this. What I will get? I will get 6 minus 4x minus x squared equal to x plus 4 the whole square. Now 6 minus 4x minus x squared equal to, now again a plus b the whole squared expanded, a square plus b square plus 2ab. Okay. Now shall we bring everything to this side? So now this becomes 6 minus 4x minus x squared minus x squared minus 16 minus 8x is equal to 0. Now look into this. Minus x squared and minus x squared, it becomes minus 2x squared. Again minus 4x minus 8x will become minus 12x. Again plus 6 and minus 16 will become minus 10 is equal to 0. Now look into this. Now we have, since we don't have, we don't prefer to have the minus in front, isn't it? So throughout we'll multiply it by negative sign. Now very specially the inequality is not given here. It is given to be equal to. So there is no problem to change the inequality. So this becomes 2 plus 2x squared plus 12x plus 10 is equal to 0. Since it has a common multiple 2 over here, shall we divide it by 2? Of course, we'll get x squared plus 6x plus 5 equal to 0. Now, I am going to factorize this equation 5. I am going to split it into two numbers. So, what are the numbers? 5 and 1. If I multiply 5 and 1, I will get 5. If I add 5 plus 1, I will get plus 6. Okay. Now, the numbers, factors is x plus 5 and x plus 1 is equal to 0. So, now what are the values now? X takes the value minus 5 and minus 1. Okay. Now, look into this condition. What is the condition? Eligible condition for this equation? X should definitely be greater than or equal to minus 4. So, which is the value? Does this x is equal to minus 5 be eligible? No, definitely not, because minus 5 is less than the value minus 4. So, this value x is equal to minus 5 is not possible according to the condition given. Therefore, x is equal to minus 1 is the solution. Did you understand, students? Is it clear for you? Okay. So, now x is equal to minus 1. Does this satisfy this condition? Yes, of course. This minus 1 is greater than or equal to minus 4. Is it clear, students? Okay, students. Let's discuss the topic rational function. You know what is meant by a rational number, isn't it? A rational number is a number which can be expressed in the form p divided by q. Yes and no? So, already we have learned this in our previous classes, and also in our 9th standard we had a very elaborate session on rational numbers. Okay. Now, what is meant by a rational function? It's also very simple. The function which is going to be in the rational form is said to be a rational function. Once again, a function which is in the form of a rational is said to be a rational function. Let's discuss into the definition now. Now, look into this. A rational expression of x is defined as the ratio of two polynomials in x. Say p of x and q of x, where q of x is not equal to 0. Now, look into this very simple definition, a rational expression of x. What does it mean? The function is in the variable x. So, a rational expression of x is defined as a ratio. What is meant by the ratio? In simple words, we can say it as a division. Is it no? Okay. So, it is a division of two polynomials in x. What does it mean? Polynomial, we know what is monomial expression, binomial expression, polynomial expression, isn't it? Poly means many. If I have many terms in an expression, then it is said to be a polynomial expression in x. Now, it is given to be as p of x and q of x, where q of x is not equal to 0. Now, in this, that is, I can say it as p of x and q of x, that is p of x divided by q of x. P of x divided by q of x. So, now look into this. This p of x is a polynomial expression in x and q of x is a polynomial expression in x. Now, it is expressed in the form of a ratio or a rational expression where this q of x should not be equal to 0. Q of x is not equal to 0. Why very specifically q of x is not equal to 0? This q of x is not equal to 0. Nada. This rational expression can be defined. If the denominator is equal to 0, the whole term will be undefined. You know that. Now, in our higher classes, any number divided by 0 is termed as not defined. Infinity. Is it clear for you? In your smaller classes only, any number you will say it as 0, isn't it? Now, in your higher classes, you should say it as infinity or not defined. Okay. Now, this is said to be the rational function. Now, let's see one example of this rational functions expression. So, now look into this x squared plus x plus 1 divided by x squared minus 6x minus 5. Now, look into this. So, this is a very best example for a rational function. So, again, this one let us take it as p of x and this as q of x. Okay. So, any expression of this form is termed as rational function. Is it clear? Okay students, let's see the exercise 2.8. The same old procedure, only the slight difference is here we are going to discuss the rational function, that's all. Okay, the same procedure what we have done in our 2.5 exercise, we will continue in this 2.8 also. Okay, now look into this. The first procedure is we are going to, here we are not going to solve the quadratic equation because already it is given to be in factors, isn't it? So very directly from the factors we are going to assign the critical number. After finding the critical number, with the help of the critical number, we are going to draw the number line and divide the number line into the segregated intervals as the critical numbers. Okay, now after that again we are going to take one representative from that particular interval and we are going to check for which number this inequality is satisfied, that is less than 0. That particular interval will be the possible solution of this given question. Okay, shall we discuss now? Yes. Now look into this. We are going to assign 2x minus 3 is equal to 0. Apart from this inequality, we are going to just assign the value 2x minus 3 is equal to 0, x minus 2 is equal to 0 and x minus 4 is equal to 0. So now what are the values? 2x is equal to 3. So x is equal to 3 divided by 2. Now again x minus 2 is equal to 0 means x is equal to 2. Now x minus 4 is equal to 0 means x is equal to 4. Now look into the critical values now. X is equal to 3 by 2, x is equal to 2 and x is equal to 4. Now what we are going to do? We are going to separate the number line which has minus infinity to plus infinity with 0 according to this critical number. Now look into this. 3 divided by 2. What is 3 divided by 2? That is 1.5. Approximately here 3 divided by 2. The next number is x is equal to 2. The next number is approximately 4. Okay. Now look into this. We are going to segregate this interval as minus infinity to 3 by 2. Again 3 by 2 to 2 and again 2 to 4. Yes or no? Now what are the intervals now? First one minus infinity comma 3 by 2. Second one 3 by 2 comma 2. Third one 2 comma 4 and fourth one 4 comma infinity and 4 comma infinity. So these are the intervals has to be checked and we are going to take one representative out of this interval and we are going to check for which value of this interval suits this inequality. Shall we? Okay students, let's discuss now. Now look into this. We have drawn the tabular column. Now we have segregated the intervals given minus infinity comma 3 by 2, 3 by 2 comma 2, 2 comma 4 and 4 comma infinity. Now what we are going to do? We are going to choose one representative from this interval. Now minus infinity comma 3 by 2. 3 divided by 2 is 1.5, isn't it? Shall we take, so till 1.5 I have minus infinity to 1.5. So shall we take the value of x to be 1 here? Okay, fine. Now again 3 by 2 comma 2, between 3 by 2, 1.5 to 2. What number shall we have? Approximately x is equal to 1.8. Shall we take it as 1.8? Okay. Now look into this. Between 2 comma 4. Shall we take x is equal to 3 here? Okay. Now in this 4 comma infinity, shall we take x is equal to 5? Just to check the values alone. Yes. Now look into this. I have taken x is equal to 1, isn't it? Now 2 into 1. 2 ones are 2 minus 3. So the sign will be minus, isn't it? 2 minus 3 is minus 1. So the sign of this term is minus. Now again 1 minus 2 is minus. Minus 1 I'll get. Again the sign is minus. Again 1 minus 4 will give you minus 3. Again the sign is minus. Now look into this. I'm going to check the sign of this one. 2x minus 3. What is the sign? Minus. Here this is also minus and this is also minus. Minus into minus will become plus. So the numerator holds minus. Minus divided by plus will give you the sign what? Minus. Yes or no? Minus divided by plus will give you the sign minus. Okay. Now look into this 1.8. Isn't it? Now 2 into 1.8 approximately what will be the answer? 3.6. So 3.6 minus 3 will give you 0.6, isn't it? So it is positive. It is positive. Now look into this. 1.8 minus 2 will give you what? Negative. Minus 0.2. Okay. Now look into this again. 1.8 minus 4. So minus 4. So you will get minus sign. Okay. Now you check it properly. When you substitute and see, you calculate, you can do it in your rough column and check it. Okay. Now again let's check it. The numerator is positive. The denominator is negative into negative. Minus into minus will become plus. So again numerator is positive. Again the denominator is positive. So the answer will be positive. Yes or no? Okay. Now look into this. If I take the value x is equal to 3. Now what will be 3? 2 3s are 6. 6 minus 3 is 3, which is positive. Yes or no? Okay. Now again 3 minus 2 is plus 1. Again it is positive. Now again 3 minus 4. 3 minus 4 is minus 1, which is negative. Now look into this. So now numerator is positive. Plus into minus will be negative in the denominator. So positive divided by negative will give you the answer as negative. Okay. Now look into this. 4 comma x is equal to 5. Now 5 2s are 10. 10 minus 3 is what? 7. It is positive. Now 5 minus 2 is 3. Again it is positive. Now 5 minus 4 is again plus 1. It is positive. So all the three terms are positive. So again the final answer is negative. Now look into this. Now we are going to check this inequality for which the value is less than 0. For which the value is less than 0. So now less than 0 means it has to hold the negative symbol. So for how many intervals we have negative? This one and this one. Yes or no? So for the interval minus infinity comma 3 by 2 and for the interval 2 comma 4, open interval 2 comma 4, this inequality is satisfied. Therefore the solution of x belongs to this particular interval. So how can I conclude? X, therefore x belongs to minus infinity comma 3 by 2 union 2 comma 4, because we have both the intervals, isn't it? So you have to use a sign union. So therefore the solution x belongs to this is the final answer. Is it clear? Okay students, let's discuss the third sum now. Solve x squared minus 4 divided by x squared minus 2x minus 15 is less than or equal to 0. So as usual, first we are going to solve the given quadratic equation separately. Now numerator separately and the denominator separately. We are going to solve it and find the critical number. Okay. Now look into this. X squared minus 4 is equal to 0. So x squared is equal to 4. So x is equal to plus or minus 2, isn't it? So x takes the value plus 2 comma minus 2. The next one, x squared minus 2x minus 15 is equal to 0. So now simple factorization, minus 15, split it into two numbers. I should get minus 2, isn't it? So I'll get minus 5 plus 3. Yes or no? Look into this. Minus 5 into plus 3 will give you minus 15. Minus 5 plus 3 is equal to minus 2. Okay. So now x minus 5 into x plus 3 is equal to 0. So x takes the value plus 5 comma minus 3. Now look into the critical numbers. What are the numbers we have? Minus 2 comma plus 2, minus 3 comma 5. Okay. Now with the help of this, I am going to segregate the number line, divide the number line, isn't it? Now which is the least value here? Minus 3, and then comes the minus 2, and then comes plus 2 and 5. So after minus infinity, approximately, shall we hold the minus 3 here? Okay, minus 3, minus 2, and this is plus 2 and 5. Okay, is it clear? Now look into this. What are the intervals we can use it? Minus infinity comma minus 3, again minus 3 comma minus 2, and minus 2 comma plus 2, plus 2 comma 5, and 5 comma infinity. Now look, what are the intervals now? This is the first interval, that is minus infinity comma minus 3. What is the second interval? minus 3 comma minus 2. Yes or no? What is the third one now? Third one is minus 2 comma plus 2. What is the fourth one? 2 comma 5, and the fifth one is 5 comma infinity. Yes or no? Look into this. So we have segregated the number line into 5 different intervals. Now what we are going to do? We are going to plot this in a tabular column, and we are going to take one representative out of these intervals, and I am going to check for which value of this interval will suit this condition. Okay, so after checking into it, now I am going to refer to the particular interval for which the value of x is less than or equal to 0. Shall we? Okay students, let's discuss this in the tabular form. Okay, so as we said, we have segregated the intervals as minus infinity comma minus 3, minus 3 comma minus 2, minus 2 comma 2, 2 comma 5, and 5 comma infinity. Now shall we take the values of x here between minus infinity comma minus 3. So minus infinity comma minus 3, shall we take it as minus 4? X is equal to minus 4, and then comes a minus 3. Okay, now look into this, minus 3 comma minus 2. So I can take it as minus 2.5. Look into this, minus 3, minus 2.5, and then comes minus 2. Now minus 2 comma 2. So very simply we can assign x is equal to 0. Now 2 comma 5, I can take x is equal to 3. Now 5 comma infinity, x is equal to 6. Okay, now shall we check the values? Now sign of x plus 2 minus 4 plus 2 will give you minus sign. Yes or no? Minus 4 plus 2, minus 2 is answer, so minus. Minus 4 minus 2 will give you minus 6, again the sign is negative. Minus 4 minus 5 minus 9, again the sign is negative. Minus 4 plus 3 will give you minus 1, again the sign is negative. Now look into this, these two are numerator signs and these two are denominator sign. So minus into minus is plus, again minus into minus is plus. Plus divided by plus will give you plus sign. Yes or no? Okay. Now look into this one, minus 2.5, minus 2.5 plus 2 will give you minus 0.5. So the sign is negative. Again minus 2.5 minus 2 will give you minus 4.5. Again the sign is negative. Now minus 2.5 minus 5, again the sign is negative. So it is negative. Minus 2.5 plus 3 will give you plus 0.5. So the answer is positive. Now look into the signs now. Numerator minus into minus will become plus. Whereas minus, denominator minus into plus will become minus. So plus divided by minus will give you the answer as minus. Yes or no? Okay. Now look into this. X is equal to 0. Substitute x is equal to 0. 0 plus 2 will give you plus 2. So the sign is plus. 0 minus 2, the sign is minus. 0 minus 5, the sign is minus. 0 plus 3, the sign is positive. Okay. Now look into this numerator. Plus into minus is minus. Again minus into plus is minus. So we have numerator also we have minus and denominator also we have minus. So minus and minus is getting cancelled. So the answer will be positive. Okay. Now look into this. X is equal to 3. 3 plus 3 plus 3 plus 2 will give you plus 5. So the sign is positive. 3 minus 2 is plus 1. So the answer is positive. Now 3 minus 5 is minus 2. The answer is negative. Now 3 plus 3 plus 6. So the sign is positive. Now look into this. Again numerator plus into plus divided by minus into plus. So minus into plus will become minus. So numerator has plus, denominator has minus. So the final answer will be minus. Yes or no? Okay. Again discuss. X is equal to 6. 6 plus 2, 8. It is positive. Again 6 minus 2. It is positive. Now again 6 minus 5 is 1 plus 1. It is also positive. Now 6 plus 3 is 9. Again it is positive. Now look into this. All the signs are positive. All the 4 terms are positive. So the final answer will also be positive. Okay. Is it clear, students? Okay students, so we have discussed the signs, isn't it? How are the signs? Okay, so once again, so you look into this, we have the positive sign for this interval and negative sign for this interval, positive sign for this interval, negative sign for this interval and positive sign for this interval. Now the given question is x plus 2, that is the factorized form, x minus 2 divided by x minus 5 into x plus 3, which is less than or equal to 0. So the inequality given is it should be less than or equal to 0, isn't it? So what does it mean? The sign should be negative. So the eligible intervals are these two. What are they? Minus 3 comma minus 2 and 2 comma 5. Now looking at this extreme values, they are continuous, isn't it? Minus 3 comma minus 3. So minus infinity comma minus 3, again minus 3 comma minus 2, again it comes with minus 2 comma 2, 2 comma 5 and 5 comma infinity. These extreme ends are continuous. So what we are going to do here, now we are going to conclude that the possible values which satisfies this condition is x belongs to open interval minus 3 comma minus 2, closed interval, union, closed interval, 2 comma 5, open interval. So now this is going to be the solution of this problem. Okay, so open interval minus 3. Why we are using closed interval here? Since the extreme points are continuous over there. Okay, so very simple procedure. So first we are going to solve the quadratic equation and we are going to find the critical number. After finding the critical number, we are going to segregate in the number line and divide the intervals and choose a point as a representative to check for this condition, check for this interval which suits this condition and conclude the answer with the particular intervals. Is it clear, students? So what you are going to do? You are going to do exercise 2.8 first sum as homework and also the example sum related with this exercise 2.8. Okay students, thank you.